Hello class. For today's lesson is about simplifying expressions using the laws of positive and zero exponents. And here is the learning target. I can apply the laws of positive and zero exponents to simplify algebraic expressions. Let's have some key terms and definition, starting with exponent and base. An exponent is a number that tells how many times a base is multiplied by itself. And a base is a number or variable being multiplied. Now, if we were to write, for example, a cubed, we have here a as our base, and 3 here is our exponent. Same thing with what is defined here. The base could be a number, not just a variable. So if we are to write 5 squared, so here we have 5 as our base, and 2 is our exponent. Which only means that if you're going to expand a cubed and 5 squared, it would look like this. For a, we have this a times a times a. So it looks like this. For 5 here, we have 5 times 5. Now, here's the thing. There are many ways in how to read, or for example here, the a cubed. So first we have here, so a cubed. Another thing, a to the third power. I know this is a misconception on how people read this. Even in my elementary years, we used to read this as a to the power of 3, but to formally read this or say this properly is a to the blank power. It depends on which rank the exponent is. So for this one here, we have a to the third power instead of a to the power of 3. And last one, in which this is the safest way to read this, would be a raised to 3, since our exponent is 3. For example, here we have the 5 squared. So just like what I have said just now, so we have here 5 squared. Same thing with the one above. So 5 to the second power. Again, this is the rank of this one instead of saying 5 to the power of 2. And last one would be 5 raised to 2. Now, what if we're not using the terms cubed and squared, given the 3 and 2 here? So if you are to choose or use other numbers, perhaps, okay, let's erase these for now. We could use any number aside from 2 and 3. So we have here, if you want to have a variable, just say b, and then we have 10, or any number that you like to use. So based on this one, we cannot say b cubed because cubed is under 3 and squared is under 2. So that means we cannot use b squared and b cubed this time. So if you have other numbers aside from 2 and 3, it could be 1, 1, 4, or any number aside from those two. You could read them like this. So b raised to 10. And just like the other one before, so we have b to the 10th power. So that's just it on the first key terms and definition for exponent and base. Third, we have the product of powers rule, which means when multiplying the same base, all you need to do is to add the exponents. Now here's a general ruling or a formula for this. Now a raised to m times a raised to n. So equals, again, copy the base, so a, and then add the exponents. So instead of multiplying m times n, again, just add. So m plus n. Now, for example, with the one earlier above, so we have, remember, the a cubed. So if you have here a times a times a, based on this, we have the same base, a. So for this one, we just need to copy this, a. And just don't forget that all numbers, for example, a, or even, let's just use 3, we have an invisible exponent, which is 1 and 1. They're just invisible. So even though you can't see the exponents here, okay, the invisible one here, so just remember that there is an exponent 1. So all you need to do is to add them. So 1 plus 1 plus 1. So you get a, and then 1 plus 1 plus 1 is 3. That's why you get to have a cubed. Now, what if we don't use this one? Let's try another variable. So a raised to 8. Oops, sorry. So if we try a raised to 8 times a raised to 5. Again, we need to make sure that they have the same base, because if they're not, then the product of powers rule will not be applied. So again, same base, so just copy, and then 8 plus 5, which is obviously 13. And this is your answer. Okay. So what if you are given like this, a raised to 10, and then b raised to b squared. So based on this, since they don't have the same base, just copy. So a raised to 10 and b squared, then this is your answer. I hope that's clear. Now, I will erase these. So we're done with the variables. Now let's have numbers. Same, let's try the 5 squared earlier. So if you have here 5 times 5, obviously this is just 25, right? But if we're going to, incorporate the product of powers rule, so we have here same base, we have 5 and 5. So we have it here. If we are going to have this one and this way, so copy the base, and then we have an invisible 1, invisible 1. So we have here 1 plus 1, 1, which is 2. That means 5 squared, and we're just going back to the final answer, which is 25. Now, if we are going to use a different number, let's just say 4. So 4 cubed times 4 squared. So same with this. So we have here, again, they have the same base, so you could just copy. So 4, and then 3 plus 2, we have 5. So 4 raised to 5. And for now, I won't dig deeper on you getting the final answer, but please know that 4 raised to 5 is multiplying 4 by itself 5 times. So 4 times 4 times 4 times 4 and times 4. Okay, so this is how you expand this. However, if you'd like to multiply this one, so 4 raised to 5, or 4 times 4 times 4 times 4 times 4 is 1024. same thing earlier. Now, what if we have a different base and we're involving only numbers? Okay, let's try 2 cubed times 3 squared. Again, obviously, the base, their base are not the same, 2 and 3. So we cannot just turn magic out of 2 or 3. So instead, if you're given this kind of situation, you're gonna have this individually. So here we have 2 cubed, which is 8, then times 3 squared, which is 9. So you get to have 72. Again, this is only this is how you solve this if you are given different bases. Now let's have the fourth one, quotient powers rule. Now when dividing the same base, subtract the exponent. So it's just the opposite thing for the product of powers rule. So this time it's subtracting. So the general ruling for this or formula would be a raised to m over a raised to n equals, so a raised to m minus n. Okay, so for example, so we have here x raised to 6 over x squared. So obviously we have here, again, they need to be the same base. So since they are the same, so you could copy the base. So x. Now here, so 6 minus 2. So, oops, what happened? So we have 6 minus 2 is 4. So we got x raised to 4. And this is our answer. Now, what if they're not the same in base? So if we have x squared over y, y raised to 5 perhaps. So since again this example here doesn't have the same base, which means all you need to do is to copy. So the answer for this one is just the given, and that's it. Now another example, let's involve numbers this time. Okay, we have 9 raised to 5 over 9 cubed. So base here, same base, so 9. Just copy the base. Then 5 minus 3, which is 2. So we don't end with this kind of result, so let's expand this one. So 9 squared, or 9 times 9 is 81, and this is our answer. Now, what if our exponent would lead to a negative? Let's just interchange the 5 and 3. So again, same base, so just copy. And obviously we have here 3 minus 5. And then copy the base. And 3 minus 5 is negative 2. Again, our learning target for today is a positive and a 0 exponent. So just like this kind of result, we'll get to know more about this next time. So just hold your horses for this type or kind of result. Next, we have the 0 exponent rule, in which any non-zero number raised to the 0 power equals 1. So we have here rule, so a raised to 0 equals 1. Now, for any non-zero a. Again, our base here should not be 0. It could be any number. It could be a fraction, a decimal, a rational or irrational number raised to 0. As long as it's not 0, then the answer would be 1. For example, we have here, of course, any variable raised to 0 would be 1, obviously. But let's talk about numbers first. So if you have here 5 raised to 0, 5 raised to 0 is 1. Even if we try 5.118 raised to 0 is 1. Even if we try negative, so negative 2 raised to 0 is 1. Now let's have some recap on the following given. Let's try. Okay, we have 3 divided by 3. So obviously the answer for this one is 1. So the ruling for this one here is a number, a non-zero number divided by itself is 1, obviously. If you also try 0 divided by 3, the answer is 0. And if we reverse it, so if we have here 3 divided by 0 is undefined. Now, what if 0 is divided by 0? Again, we need to go back on this part first. It's not always a number divided by itself is 1, but the correct phrase for that would be any non-zero number divided by itself is 1. Also here, we have 0 divided by 3 is 0, but if we divide 3 with 0, it is undefined. So what happens if 0 is divided by itself? Obviously, it would not be 1 because the ruling for this is that it should be any non-zero number divided by itself. Now, it is confusing if the answer would be undefined or 0. We cannot determine which is which. That is why if a 0 divided by 0, the answer would be indeterminate. Indeterminate. Because again, we cannot, we don't know which property or ruling should be used. Is it the 3 over 3, the 0 over 3, or the 3 over 0 examples, right? So the term for this would be indeterminate. Now, let's go back to the zero exponent rule. How is this connected in any sense? Now, let's erase this first. I'm gonna start with a variable. So we have a squared and a squared. First thing, is our numerator the same with the denominator? Obviously, they're the same. So it's just like any non-zero number divided by itself is 1. So with or without knowing the zero exponent rule, the answer would be 1 right away. But let's apply the principle of zero exponent rule. So again, do they have the same base? Yes. So we just copy A. Now we have here 2 minus 2, which is equal to 0. So obviously, based on this one, based on our ruling or formula here, that means A raised to 0 is 1. Another thing, if we have A raised to, or no, let's have a number. We have negative 10 divided by negative 10. So obviously, where is it? So obviously we have the same numbers. So with or without knowing the zero exponent rule, the answer would be 1. But again, let's just go back to the rule of this. So do they have the same base? Yes. And the base is negative 10. Again, you don't see an exponent, but without seeing the actual exponent, we know for sure that any variable or number without an exponent, based on what we see, has an invisible 1. So based on this, 1 minus 1 is 0. So we get to have negative 10 raised to 0, which is 1. And that's it. Next, we have power of a product rule. So it is when raising a product to a power, distribute exponent to each factor, or base. So we have here a, b raised to n. So we distribute the exponent to each of the base. So you have here a raised to n and b raised to n as well. Now here's an example. This will involve a variable and its coefficient. So you have here 2x 2x cubed. Sorry. So base here, again, we get to distribute the exponent to each of the base or factor. So we have here 2 cubed and x cubed. Actually, we're not done yet with this one because we could still expand or get the final answer for 2 cubed, which is 8. So based on this, 2 cubed or 2 times 2 times 2 is 8. So the final answer would be 8x cubed. Now, next, let's have this one. So 3m n squared. So again, you distribute the exponent to each of the factor. So we have here 3 squared, m squared, and n squared. Again, we're not done yet with 3 squared because this one here can still be simplified. So with this, 3 squared is 9. So our final answer would be 9m squared and n squared. So that's it. Now, what if we are given something like this? I'm gonna use 5x squared and cubed. So obviously, based on the previous examples, you could just have 5 and the cube, so 5 cubed. But here, we now have a squared, and cubed. All we need to do if an exponent has an exponent is to multiply the both of them. So 2 times 3 is 6. So we get to have x raised to 6. Unlike with the previous rule in which, remember this one, a times a, we just need to add the exponent. However, on this power of a product rule, we need to get to have them being multiplied. So yeah. So but we're not done yet, again, because we have here a 5 cubed. So 5 cubed is 5 times 5 times 5, which is 125. And then copy x raised to 6. And this is our answer. Now, last example for this rule, let's have this one. For a raised to 5, b 3, okay, and cubed. Okay, so again, we have this 4 cubed, so we distribute 4 cubed, and then an exponent has an exponent. So if we have an exponent, we multiply. So 5 times 3 is 15. So a raised to 15. And same thing with b cubed. Raised to 3 is 3 times 3, which is 9. So b 9. But again, we're not done yet with 4 cubed. So 4 times 4 times 4 is 64. So our final answer would be 64 a raised to 15 b raised to 9. And now let's have the last exponent rule for the day. We have the power of a quotient rule. Now when raising a fraction to a power, distribute the exponent to the numerator and denominator. So we have this one. So a over b n equals to a raised to n over b raised to n. The same thing with the rule earlier. We just need to distribute for both numerator and denominator. So for example, we have here x over 2 squared. So here, distribute the exponent to the variable. So we have x squared and we have 2 squared. But we must not stop with this one because 2 squared can still be simplified. So we have here as a final answer, we have x squared over 2 squared, which is 4. Another example, we have here 3a over 5b cubed. So we have 3 raised to 3 and then a cubed. Also have 5 cubed and b cubed. So we're good with the variables. However, we are not done with the numbers themselves. So 3 cubed is 27 and then a cubed over 5 cubed is 125 b cubed, and this is our answer. Now, how about this one? 2 cubed and raised to 4 over 3 and cube raised to 4. Now, I will give you 2 options in how to solve this. Let's have option 1. So for option 1, you get to distribute the exponent 4 to all of them for both the numerator and denominator. So we'll have it like this. We have, for option 1, we get to have 2 raised to 4. 3 times 4 is 12. And 4 times 4 is 16. Over, you have here 3 raised to 4. And then 3 times 4 is 12. So n raised to 4. So based on this, we could simplify, aside from the numbers, we can simplify variables n raised to 16 and this one as well, because they have the same base. So basically, we're just applying the previous rule that we had earlier. So we have here, so if we're going to have this one, so 2 raised to 4 is 2 times 2 times 2 times 2 times 2 times 2 times 2 is 16. And then m raised to 12. And then 16, oops, what did I write for? Sorry. This one here is supposed to be 12. Now, 16 minus 12 is 4. So we get to have n raised to 4 over 3 raised to 4. 3 times 3, 9 times 3, 27 times 3, 81. Okay? And this is our final answer. 16 raised to 12 and raised to 4 over 81. Now, second option would be, okay, let's erase this. Option 2. So we have here 2m cubed n raised to 4 over 3n cubed. Okay. Based on this, before we could distribute the exponent 4 to each of the base or the other exponent, since we have here same base and n, we could derive the exponents right away before distributing this exponent. So based on this, we get to have 2m cubed, and again we have here n, so n 4 minus 3, which is n raised to invisible 1, or just n. So n over 3, and then we get to have the exponent 4. So same earlier, we have 2 raised to 4. 3 times 4 is 12. And n, again, we have an invisible 1. So 1 times 4 is 4 over 3 raised to 4. So same thing earlier's answer. So we get to have 2 raised to 4 is 16. M12, m raised to 12. N raised to 4, and 3 raised to 4 is 81. And that's it for today.